You know, the world is absolutely swimming in data. It feels like this chaotic sea of numbers. But what if I told you that hidden inside all that mess are these simple, elegant shapes? Shapes that can help us figure out not just what's happening now, but what might happen next. Okay, let's dive right in.
So here's a bit of a riddle for you. What could possibly connect drunk driving data with how we all started carrying cell phones? It sounds completely random, right? But the answer shows us something really fundamental about how change happens. Both of these things, believe it or not, follow a predictable mathematical shape.
So how do we find these shapes? Well, our number one tool is the good old scatter plot. Seriously, this is how we turn a boring spreadsheet into a picture, a visual story. It's basically our magnifying glass for finding the clues that are hiding in plain sight.
All right, so let's start our investigation. We're going to go on a hunt for the story that these numbers are trying to tell us. And we're going to be looking for three very specific, very powerful patterns that, once you see them, you'll start noticing everywhere.
Our first case file, I like to call this one the rocket ship curve. And for good reason. This is the kind of data that looks kind of innocent at first. You know, it starts off slow, stays low to the ground, and then suddenly, whoosh, it just ignites and shoots straight for the sky.
Let's look at some real numbers from a university study on driving risk. On the left, you've got blood alcohol content, or BAC, and on the right, you have the relative risk of getting into a crash. Now, as that BAC number on the left goes up, just watch what happens to the risk number. It doesn't just climb, it absolutely leaps.
And that right there is the key. This isn't a straight line. It's not like each drink adds the same amount of risk. No, each one adds more danger than the one before it. The risk isn't just growing, it's accelerating, it's picking up speed.
This kind of runaway acceleration has a name. It's called exponential growth. The defining feature is that ever-increasing speed. It starts slow, then gets faster, and faster, and faster, and it feels like there's no ceiling in sight.
So what's the bottom line here? It's pretty terrifying. Using the model from this data, a person with a BAC of 0.16, which is roughly 6 drinks for a 160-pound person, is more than 26 times more likely to crash than somebody who's sober. That is the incredible power of this rocket ship curve.
But let's be realistic. Not everything can just shoot for the stars forever, right? Things run into limits. So what happens when growth can't go on and on? Well, that brings us to a totally different kind of pattern. One that starts out fast, but then, eventually, it starts to chill out. Okay, on to our second pattern, what I call the curve that matures. This describes things where you see these huge, amazing improvements right at the beginning, but then over time those gains get smaller and a lot harder to come by.
Just take a look at the data for U.S. life expectancy. Back in the first half of the 20th century, we saw these massive jumps. I mean, huge gains from things like sanitation and basic medicine. But now look at the more recent numbers. The gains are so much smaller. We're still making progress, but the pace has clearly slowed way down.
And this pattern is called logarithmic growth. You know, it's a lot like learning a new skill. Think about picking up a guitar. In your first few weeks, you make huge progress. You learn chords, you can play a song. But going from a pretty good player to a true master, that takes years and years of practice for tiny little improvements. That is the shape of this curve.
And here's where it gets really useful. This shape becomes a predictive tool. The logarithmic model that fits this data, it suggests that by 2030, the average life expectancy is going to creep up to about 79.1 years. It's a small gain, which is exactly what the curve tells us to expect.
So we've seen growth that just explodes upwards, and we've seen growth that gets tired and slows down. Our final pattern basically puts them together. It tells the complete story from start to finish, the story of the inevitable plateau.
And what's the perfect example? Cell phones. I mean, we all lived through this. Look at these numbers. It started off slow in the 90s, right? Then it just exploded in the 2000s. It felt like everyone got one overnight. And now, well, it's pretty much leveled off. And the reason is simple. Almost everyone who is going to get a cell phone already has one.
This point where things level off is a super important idea called the carrying capacity. It's just the natural ceiling for growth. For cell phones, the carrying capacity is basically 100% of the population. You just can't sell more phones than there are people to buy them. It's a natural limit.
So this whole process creates this beautiful S-curve that tells a complete story. You've got phase 1, slow adoption, the early adopters. Then phase 2, that explosive rocket ship growth as it goes mainstream. And finally phase 3, market saturation, where growth slows to a crawl because it's hitting that carrying capacity. Okay, so we've put together a pretty powerful toolkit for seeing how the future takes shape. But, with great power comes great responsibility. There is one last crucial piece of advice we have to talk about before we start trying to predict everything.
So here it is, our pattern spotting toolkit. You've got three distinct shapes: the rocket ship of exponential growth, the maturing curve of logarithmic growth, and the whole life cycle S-curve of logistic growth. These three stories help us make sense of the world.
And here is the big flashing warning sign, straight from the source material. It's really dangerous to just extend a pattern way out into the future. It's called extrapolation, and you always have to stop and ask yourself, does this still make sense? A pattern that held for 10 years might not hold for 100.
So, at the end of the day, that's what we have to remember. These models are incredible maps. They are fantastic for understanding the direction things are heading. But they are not crystal balls. They show us the mathematical shape of reality, but reality itself, well, it's always going to be a little bit messier. Which really just leaves us with one final question for you. Take a look around at the world. New technologies, social shifts, whatever. What future trend do you see taking shape right now? Which one of these curves is it following? What's the story that data is telling you?